polynomial involve only non-negative integer powers of x. So for example, if we have fx equal to x plus 4, this one, what important is the power, this one. The power is 1. It should be non-negative. Another example is fx equal to x square plus 2x plus 3. Or fx is equal to, if we have power 3, x power 3, so this one polynomial of degree 3, minus x square plus 6. All this, the domain is always real number, r. We write like this, or we can write minus infinity, infinity. Or you can also write in full sentence, all real numbers. Also, you should not forget that fx equal to a number, a constant, for example 4. This is also a polynomial. So the domain for this also all real numbers. Another example is minus pi. Pi is a number, a constant. And don't forget 0. And also, if involve radical, like this, cert 3. This one also polynomial. What important is the power of x. No negative. And it should be integers. 3, 2, 1. We don't write the 1. This one, x power 0. So, the domain is all real numbers. Next one is rational function. Rational function, both numerator and denominator are polynomials. Remember, polynomial, the power should be non-negative of x. The power of x should be non-negative. So, for rational function, numerator and denominator are polynomials. So, for example, we have fx equal to 1 over x plus 4. This one polynomial. The numerator also polynomial. Polynomial over polynomial. The domain is all real numbers except for x that makes the denominator become 0. So this one, this part, the denominator will become 0 if x plus 4 equal to 0. So x equal to minus 4. The function cannot accept minus. If you substitute minus 4 inside here, minus 4 plus 4 is equal to 0. So you get 1 over 0. It doesn't exist. So what you need to do, this is the domain. So the domain is, the domain of f is everything, all real numbers, except for minus 4. You can also write like this, minus infinity, minus 4, union, 4, minus 2, positive infinity. Or you can also write all real numbers except minus 4. It's okay. Let's look at another example. fx equal to 2 over x square plus 3. This time, there is no number that we can substitute into x that makes the denominator become 0. X squared plus 3 is equal to 0. X squared is equal to minus 3. So, since we are talking about real numbers in calculus, so x is undefined. So, this one is undefined. Okay. It means that this denominator cannot be 0. Since it cannot be 0, so the domain of f is all real numbers. This one all real numbers, the numerator. This one also all real numbers, the denominator. So the domain of f is all real numbers. Next, domain for radical function. What is radical? Radical is a function that involves square root symbol. This one is square root, but it's radical. You can also have cube root, fourth root, fifth root. Everything is called radical. The one inside is called radicand. This one is radical symbol. Inside radical symbol, you have radicand. And sorry for the if the number here is even 2, 4, 6, the domain is greater than or equal to 0. For example, 2. So the domain, everything inside here must be greater than 0. If you have odd number here, cube root, fifth root, seventh root, so in here, the domain is all real numbers. Let's look at an example. For example, you have fx equal to square root x plus 3. Everything inside here, the radicand should be greater than 0. So, x plus 3 greater than, and it can accept 0 also, equal to 0. So, x should be greater than or equal to minus 3. If you substitute a number that is less than minus 3, you will get a negative number for radicand. And the function will not define. So, the domain is, you can write, this one includes, so square bracket, minus 3, infinity. Or if you lazy, you just write, this one also can. Let's say we have a square, degree 2 polynomial. There is no x that we can substitute into this expression that make it become 0. Because you have plus here. Square, it makes all positive. So, x square plus 3 greater than or equal to 0. X square greater than or equal to minus 3. This is undefined. So, the domain is all real numbers. Next example. So we have fx equal to square root x square plus 2x minus 8. Like this. So the radicand should be greater than or equal to 0, x square plus 2x minus 8 greater than or equal to 0. What we need to do is we need to find x so that this one become true. So we do factorization to find the factor. It's very easy. X 8 is 2 times 4. This one minus, so either minus here or minus 2 times 4 or 1 times 8. 1 minus 8 minus 1 and 8. And then we need to have 2. So if we add this one, 1 minus 8 is minus 7. Minus 1 plus 8 is 7. You will not get 2. So this one, 2 minus 4 is minus 2. Minus 2 plus 4 is 2. So this one is plus 4 and minus 2. This is the answer. But you can also use your calculator. In order for this to become greater than or equal to 0, we have this one positive, or x plus 4 negative, x minus 2 negative. So x plus 4 greater than or equal to 0. So x greater than or equal to minus 4, and x minus 2 greater than or equal to 0, x greater than or equal to 2. This one, if you draw the line number, you have minus 4 and 2. So the area is this one. For minus 2 is this. The intersection is this one. N is intersection. So from here you have x greater than or equal to 2. The other one is x plus 4 is less than or equal to 0. So x less than or equal to minus 4, and x minus 2 less than or equal to 0. So x is less than or equal to 2. The line number like this. So minus 4 and 2. You have less than 2 and then less than minus 4. So this is the area. So from here you have x less than or equal to minus 4. So the answer is this one and this one. Two answers. Okay, next is exponential function. So exponential function is, you have, in easy word, it's like fx equal to, you have a number, constant like this. X is the exponent. Normally you have x square, But exponential function, you have the constant here, and then the power is x. This is quadratic, this is exponential. So the domain of f for exponential function is always R. Next one is logarithmic function. Logarithmic function is the inverse of exponential function. Example, you have fx equal to log 2, log 3, log 10, or ln, log base e. Everything is the same. S plus 3. For this one, the one inside log should be greater than 0, because log 0 does not exist. So, x plus 3 is greater than 0. No equal sign. Remember, for square root, this one greater than equal to 0. This is square root, the radical. This one radical. But for log, no equal sign. So, x greater than minus 3. So, the domain of f is equal to open interval minus 3 infinity. Another example, fx equal to log x square plus 3. Inside log greater than 0, x square plus 3 greater than 0. Since this one plus, this one square, this one always positive, plus 3 always positive. So, this one, the expression here, will be always positive. Therefore, you cannot find x that makes this one become 0 or negative. So, the domain of f is all real numbers. All x. Any numbers. You can substitute any numbers, and this one is defined. Next example, fx is equal to log x square plus 2 x minus 8, like this. The function inside log should be positive, but not 0. So, x square plus 2x minus 8 greater than 0. You need to find the x. This one greater than 0. So, you do factorization, or you can use your calculator. It's okay. Minus 2. So, x plus 4 greater than 0 and x minus 2 greater than 0, positive, or x plus 4 less than 0 and x minus 2 less than 0. So, x plus 4 greater than 0, so x greater than minus 4, and x minus 2 greater than 0, x greater than 2. So line number minus 4, 2, this one, and this one. Okay. The answer is x greater than 2. The other one, or x plus 4 less than 0 and x minus 2 less than 0. Negative time negative is positive. You need positive. So x less than minus 4 and x less than 2. This one, we draw the line number x. This one minus 4, this one 2, this. So x less than minus 4. So the domain is equal to this one greater than 2. So minus infinity to minus 4 union to infinity. Next we have fx equal to square root x plus 3 over x minus 2. Now a combination. This one not rational because involve radical. So first we take a look at the denominator. Denominator x minus 2 cannot be 0. So x equal to 2. And the other one is for the numerator x plus 3 greater than radical half equal, log not equal 0, x greater than or equal to minus 3. The line number, you have minus 3, you have 2, not equal to 2, so equal to minus 3 to 2 and this one. So the domain of f is equal to, start from minus 3, comma, minus 2, union, minus 2, infinity. Do we also need to do the red part? Oh, this question. Do we need to do the red part? Yes. We need to do this. Hello, good morning, hello. Assalamualaikum, waalaikumsalam Zafran. Okay, can we proceed? Okay, another example. Fx is equal to square root x plus 3 x square minus 16. Numerator x plus 3 greater than 0 with equal sign. Oh, we have done this. Then this one greater than minus 3. And then the denominator, x square minus 16 is not equal to 0. So x square not equal to 16. So x not equal to plus minus 4. We have plus minus because even function square. Now the line number. Sorry. We have minus 3. We have 4. So from here to minus 4, not include minus 4, and up to here. So the domain is minus 3, 4, union, 4, infinity. Okay, so we finish finding domain. That one, finding domain. The next one is limit and then continuity. Limit is easy. You have limit, let's say x approaching 3, x plus 2. I will not talk about the concept of limit. I will focus on how to solve, how to compute the limit, so that everybody will pass the exam, inshallah. This one is very easy. Whatever you approach here, x is approaching 3, so you substitute 3 into x. So you will have 3 plus 2 equal to 5. That's it. Let's look at another example. Let's say we have x approaches 3, x square plus x plus 2. Now we have 2x. But don't worry, we substitute 3, whatever here, it doesn't matter. If in here you have pen, you substitute pen into x. If you have a house, you substitute a house. If this one is pi, substitute pi. 3.2, you substitute 3.2. Whatever here, x is approaching here, you substitute into x here. Whenever you have x, you change it into this number or any symbol here. A house, a tree, a number, 3.2, 4, 0.1, pi. You substitute into all x. So this one you have 3 square plus 3 plus 2. Now you solve this, you get 14. Next example. Let's say you have limit x approaches 3. Why 3? It's just an example. Don't worry about it. So you now have a rational. 4 minus x. One x here, another x here. So don't worry. You substitute, you will get 3 plus 2 over 4 minus 3. You solve this, you get 5 over 1. So this one is 5. Very easy, right? Another example. Limit x approaches 4. 4 minus x. This one equal to 4 minus 4. So equal to 0. Next one. Limit x approaches 4. 4 minus x over x minus 2. So this one is equal to 4 minus 4. 4 minus 2. 0. But this one is not 0. It's okay. The answer is 0. If the numerator 0, denominator not 0, okay. You get the answer. If the numerator not 0, denominator 0, this one does not exist. But if you have 0 over 0, then you need to do something in order to solve the limit. Okay, next one is limit example, you have limit x approaches 4, x minus 2 over 4 minus x. If you substitute 4, you will get 4 minus 2 over 4 minus 4. So the answer is 2 over 0. So this one does not exist. Does not exist. Another example, limit x approaches 2. You have x minus 3 here. So this one is square root 2 minus 3 equal to minus 1. So this one also does not exist. It's not a real number. Another example, limit x approaches 3 square root x minus 3. So this one is 3 minus 3 becomes 0 square root. So the answer is 0. No problem. What about limit x approaches to 4? Now, no x. So how to solve this? Don't worry. If you don't have the x, just copy back this one. So this one is equal to 4. No x. So don't substitute anything. Another example. Limit x approaches to pi. So no x. So the answer is pi. Whatever here, you just copy. And then another example. Limit x approaches pi 2. Now pi is here and 2 is here. So the answer is not pi but 2. Limit x approaches 4, x minus 4 over 4 minus x. Okay, so this one is 4 minus 4 over 4 minus 4. So the answer is 0 over 0. This is not the answer. You cannot write undefined. You need to do something about this. If you look here carefully, this is x minus 4 and this is 4 minus x. So you can rewrite it as this one x minus 4 and this one is minus x minus 4. Right? So this is equal to limit x approaches 4, x minus 4 and a minus 4 is equal to 1. 1 over minus 1 is minus 1. So 4 minus 1. So the answer is minus 1. Limit x approaches minus 3, x square plus 5x plus 6 over x plus 3. If you substitute minus 3 into x, you will get 0 over 0. In the exam, usually the denominator is one of the factor. What you need to do is divide this, the numerator with the denominator. So either you do synthetic division or long division. It's okay. So let's say I will show you long division. This one x square plus 5x, but you need to follow the number 2 and then it should be 1. If there's no x power 1 here, you put 0 plus 6 divided by x plus 3. So x times x, you get x square. 3 times x, you have 3x. Minus here, so this one becomes 0. 5 minus 3, 2x plus 6. X times 2 is 2x plus 6. So this one becomes 0. You minus. Okay, so the next step is this one, you have to factor out. So limit x approaches minus 3, this one x plus 3, x plus 2. In the exam, you must be able to cancel this one. If you can cancel, it means that you do this correctly. Otherwise, something is wrong. Because it's an exam question, you must be able to cancel. It's not real life. So this one equal to limit x approaches minus 3, x plus 2. Substitute minus 3 into x, you have minus 3 plus 2. So this one is equal to minus 1. Another example, limit x approaches 0, x over x plus 4 minus 2. This one also the same. If you substitute 0 into here, you get 0 over 0 plus 4 square root. This one is equal to 2 minus 2, 0. So this one also case 0 over 0. But this one, you cannot factorization, cannot do factorization. So what you need to do is, you need to rationalize the denominator of this function by multiplying it with the conjugate. If you multiply conjugate to the denominator, you have to multiply conjugate to the numerator as well. So, in here, let's solve this one first, and then we add the limit sign. X over square root x plus 4 minus 2 times. So now conjugate it is x plus 4 plus 2. That's the difference. Minus become plus. Actually, you can have minus here and this one minus. But usually we just put this one here. So plus 2. And this one is x plus 4. Why we can do this? Because square root x plus 4 plus 2 over square root x plus 4 plus 2 is equal to 1. It's like multiplying to 1. But why we want to do this? Because what we want to do is to rationalize this one. Okay. After this, you must be able to cancel out x. Otherwise, it is wrong. So next is, the numerator is easy. X times square root x plus 4 plus 2. The denominator, okay, this one you don't waste your time. This one is square root x plus 4. This one is square root x plus 4 minus and plus. So you just copy what is inside here, x plus 4, just copy. And this one minus 2 times 2 is 4. Don't waste your time. Square root x plus 4 times square root x plus 4 plus 2 times square root x plus 4 minus 2 times square root x plus 4 minus 2 times plus 2. Don't waste your time. Just copy what is inside the square root, put here, minus this part, minus this, times this part, you get this. Or you just square. If this one's 3, this one should be 3, so 3 square. But 2, now 2 square, you get 4. If you do this, you will have x square root x plus 4 plus 2 over x. At this stage, you must be able to cancel. If you cannot cancel, it means that you have made some mistake here. You must be able to cancel x. Okay? So now this one become square root x plus 4 plus 2. No more problem. So, if you solve this, the limit x approaches 0. Now this one has become this, square root x plus 4 plus 2. So this one is, you substitute 0 into here, into x. 0 plus 4 is 4, square root 4 is 2, 2 plus 2 is 4. Problem solved. Remember, multiply with the conjugate, minus, you have plus, and then this one, don't waste your time multiply 1 by 1, just copy whatever in the square root, you put here, and then this one square, you put here. This one always minus sign. At this stage, you must be able to cancel x. You can cancel, this one correct. You cannot cancel, do it again. We have looked at limit at a number. Now, limit at infinity. So what will happen if x become more very large x? So will the function increase or decrease or what? That is what we are interested in. And also for negative x. So that is limit at infinity. This one is very large or small x. We can say that. So first we have odd positive integer powers. Odd positive integer powers. For example, limit x approaches 2 of x. So this one odd power 1. So you get 2. Alright? But now, what about x approaches positive infinity x? This one you copy into x. This one also you copy into x. So it's going to be plus infinity. And if you have negative, also the same thing. X approaches negative infinity of x. So this one become negative infinity. Odd power, whatever here, you just substitute. So power 1, positive become positive. Power 3, x power 3. So this one is positive. Any number, power 3, 2 power 3 is 8. But if you have something like this, if you forgot, you can test your answer with your calculator. X power 3. This one, negative number. Negative 2 power 8 is negative. So it should be negative infinity. Okay, so even power. Now, if we have even power, x approaching positive infinity, x square. So this one is positive infinity. But if you have x approaching negative infinity, negative number, if we square it, you get positive. So even power, power 4, power 2, you should get positive. Always. Then, if you have highest degree, for example, limit x approaches positive infinity, x power 3 plus 2x square plus 3x plus 4 over, like this. What you need to do is just ignore the rest. You just take the x with the highest power. It's like you have $1 million money and then you add another 20 cents. You don't count the 20 cents because you already have $1 million of money. So this one is actually equal to x approaches positive infinity x cube. So this is positive infinity. You must be careful with the negative sign only in here. The rest, you don't care. For example, if you have limit x approaches minus infinity to x power 4 plus x plus 3. So this one you ignore. This part you ignore. You also ignore 2. So this one is actually limit x approaches minus infinity x power 4. So the answer is negative even power, you get positive infinity. Rational function. This one very special. As approaches positive infinity, 1 over x, this one is equal to 0. This is one formula that you need to remember. And if you want to solve, you have to divide the numerator and denominator by the highest power of x that occurs in the denominator. So for example, you have x approaches positive infinity, 2x plus 4 over 5x minus 3. So this one, the highest power is x. So this one you divide by x with the highest power from the denominator. So 2x over x plus 4 over x over 5x over x minus 3 over x. This one you divide x from the highest power from the denominator, from here. It's not this x, but this x. So if this one is x power 5, so you divide everything by x power 5. Okay? So it is equal to limit x approaches positive infinity 2 plus 4 over x over 5 minus 3 over x. So this part is 0 from this formula. This part also 0. Actually, power 2, power 3, power 4, power 5, it doesn't matter. As long as over x, it is 0. And this one is equal to, this one 0, this one 0. So 2, limit x approaches positive infinity, 2 is 2 plus 0 over 5 minus 0. So the answer is 2 over 5. Now we have x approaches minus infinity 2x squared plus 4 over 5x minus 3. Let's see, this one power 2, this one power 1. So divide by x from the denominator by x, not x squared, x. So this one is limit x approaches minus infinity. So 2x square over x plus 4 over x over 5x over x minus 3 over x. This part becomes 0. This part becomes 0. So this one is equal to limit x approaches minus infinity. So 2x over 5. We can ignore the constant. So you have x here. So the answer is minus infinity. It's like you have minus 1 million times 2 over 5. It's also very, very large. So minus infinity. That's why you ignore 2 over 5. For the sake of exam, just ignore. Another example. Limit x approaches positive infinity, 2x plus 4 over 5x minus 3. This one. Okay. Now you have radical. What you need to do is, this one you can take out. Find limit first of the rational function and then you solve the radical part. So, x plus 4 over 5x minus 3. I forget to put the limit sign. Okay, should be limit x approaches positive infinity, 2x plus 4 over 5x minus 3. So we solve this and then for the answer, we take the square root. This one is very easy. This one is square root. Divide by x from the denominator. So limit x approaches positive infinity. So 2 plus 4 over x over 5 minus 3 over x. This one 0, this one 0. So this one is square root 2 over 5. 0, 0. 2 plus 0, 5 minus 0. Now, radical function. Limit x approaches positive infinity. You have square root x square plus 1 over 2x minus 3. Just now, the radical is for all the expression. But this one only the numerator has the radical. So what you need to do is, you have a look at this one. If you have positive infinity, you divide by positive x. If you have negative infinity, you divide by negative x. So this one is positive infinity, you divide by positive x. This one, divide by x square. So this one equal to limit x approaches positive infinity, x square over x square. So divide by x square inside square root. For the denominator, x positive infinity divide by positive x minus 3 over positive x. Positive, this one positive. If you have negative here, this one should be negative. So this one is equal to limit x approaches positive infinity, 1 plus 1 over x square. This one over 2 minus 3 over x. This part is 0, this part is 0. So the answer is 1 over 2. let's have a look if you have x approaches minus infinity. Just now it's x approaches positive infinity, but now minus infinity, but for the same x squared plus 1 square root over 2x minus 3. The difference is this one. So this one is equal to limit x approaches minus infinity. So this one divided by x squared plus 1 over x squared. This one minus x minus 3 minus x. Okay, so this will become limit x approaches minus infinity. So 1 plus 0. This one is over minus 2 over x. Sorry, I forgot x. Minus 2. X here. So this one plus 0. Now see, you have minus 2. This one you have 2. This one you have minus 2. So the answer is 1 over 2 minus. Okay, now we look at infinity minus infinity. What to do? Okay, so let's say we have limit x approaches positive infinity square root x square minus 3x minus x. This one was infinity, this one also infinity. So we don't know minus infinity or positive infinity. So what we need to do is multiply with the conjugate again. If you have radical, one non-radical, most of the time we multiply with the conjugate to normalize. So this one you multiply with square root x square minus 3x plus x. And you divide again by the same thing. If you do this, you will get, remember, this one just copy x square minus 3x, and this one you square over x square minus 3x plus x. Remember, this one you should get a simple one. So this is x square minus x square, so you get minus 3x over square root x square minus 3x plus x. Now, what you can do is the limit x approaches positive infinity. Now, it has become like this. Square root x square minus 3x plus x. Now you already have this. It's simple now. Okay, this one positive, divide by x and x square. Positive, so negative 3x divide by x. This one square root x square divide by x square minus 3x divide by x. We should divide by positive because positive infinity plus x divide by x. So this one will become x approaches positive infinity. So this one minus 3 over square root 1 minus 3. This one x square, sorry, over x. Square root plus 1. So this one is 1 plus 1. So minus 3 over 2. This one is 0. Okay. Limit for trigonometric function. The same thing, x approaches 0, sin x equal to, just substitute into x. So this one is sin 0. Sin 0 is 0. Remember, for calculus, the unit is always radian. Limit x approaches 0, cos x plus 1. So substitute 0 into here. So you have cos 1 plus 1. 0 plus 1 is 1. Cos 1. Limit x approaches 0, cos 1 over x. So this one is, you can also do cos and then limit first. Limit 1 over x. Limit 1 over x is 0. So this is cos 0. So the answer is 1. This one is 0. X approaches infinity. Sorry, infinity. You have one special formula for trigonometry. It's limit x approaches 0, sin x over x is equal to limit x approaches 0, x over sin x. So this one is equal to 1. Okay, the formula. So limit x approaches 0, sin 3x over x. Now we have problem. This one x over x, but now we have 3x over x. So you should get the same. Never ever change this one. This one will always be 3. You need to make this one become 3 also. So what you need to do is limit x approaches 0, sin 3x. This one should be 3x, and then you get 1. But you cannot simply multiply 3 here. You divide by 3 here. You need to multiply 3. So 3 over 3, 1. You will get the same thing. So now, this one will become 3 times 1. So the answer is 3. Another example. Limit x approaches 0, sin 3x minus x cos x over x. Don't worry. This one very long. But don't worry. You can separate it into 2. So you have sin 3x over x minus limit x approaches 0, x cos x. Oh, sorry, cos 3x. So this one, we have done it previously in the previous example. So this one will become limit x approaches 0, sin 3x over 3x. This one is 1, this one is 3. Okay. This one, don't worry. First, we substitute into here. You get 0. It's okay. Substitute into here, you get 0. Cos 0 is 1. 1 times 0 is 0. So the answer is we forget 1. Sorry, I forgot x here. So this one is equal to x approaches 0 cos 3x. Now we substitute into here. So you get cos 0. Cos 0 is 1. So it is minus 1. minus 1. So the answer is 2. You also have another formula for cos. Limit x approaches 0, cos x minus 1 over x. But I will not touch this one. Okay, we have finished finding domain and limit. The next one is continuity. Continuity is easy if you know how to find limit and if you know how to find the value of a function. So f is continuous at a point if fa is defined, limit of f as x approaches a exists, and you can also say limit of f as x approaches a from right is equal to limit of f as x approaches a from left, and the third rule is the limit of f as x approaches a is equal to fa. Continuity. Okay, one example. Determine whether fx equal to 4x plus 12 over x square minus 9 is continuous. At x equal to 0. So, question mark. So, 3 steps. The first step is you check whether the function is defined at x equal to 0. Okay, step 1, we find f0. 0 comes from here at 0. So you substitute here, you have 0 plus 12. So this one 12 over 0 minus 9, 9. Negative. It exists. If at step 1, you find that this function is undefined at x equal to 0, you stop and you say that x is discontinuous at x equal to 0. So the next step is find the limit as x approaches 0. So this one is 4x plus 12 over x square minus 9. So you substitute. First substitute. You don't. If you get an answer, that is the answer. So 0, you have 12. 0 here, you have minus 9. It is exists. So the function is defined at x equal to 0, and the limit as x approaches 0 for the function also exists. Third, you check whether this value and this value is equal. See, f0 is equal to limit x approaches 0 of fx. And this one is equal to minus 12 over 9. Therefore, f is continuous at x equal to 0. Easy, right? You just need these 3 steps. If you start here, and then you say it is discontinuous. Next example, you have fx equal to 4x plus 1 over x square minus 9. X equal to minus 3. Is this continuous or not? At x equal to minus 3. Okay, first step, f minus 3. So this one is 4 times minus 3 plus 1 over minus 3 square minus 9. So this one is equal to minus 11 over 0. This one 0. If you have 0 over not 0, the answer is 0. 0 over 0, you need to do something else. If polynomial over polynomial, you do factorization and so on. Okay? So, but if you have not 0 over 0, the function is undefined. Undefined at x equal to minus 3. It means that you cannot get the answer if you substitute negative 3 into x. So, you can say that f is discontinuous at x equal to minus 3. You don't have to do step number B to find the limit, and you don't have to do step C to check whether the limit is equal to f minus 3. You stop here and say discontinuous. Okay, next example. Let's say you have piecewise function. Two x square minus 5 and 4x plus 1, x less than 3, x greater than or equal to 3. So we want to check continuous or not at x equal to 3. Continuous or not. Okay, first step, f3. F3, 3, okay, let's look here. This one less than 3, not equal to 3. So this is not the one. This one is less than or equal to 3. So this one is the one that we want. So 4 times 3 plus 1. So the answer is 12 plus 1 is 13. Okay. B, find the limit of x approaches 3 of fx. From left. This time we have from left. Fx. So this one is limit x approaches 3. No more left. Okay, which one is left? This one is 3. Greater than or equal to 3, 4x plus 1. Less than 3, 2x square minus 5. This one is less than, this one is greater than. So the answer is this one. So you substitute into 2x square minus 5. So you get 13. You need to find from left and from right because you have different function from left and from right. So the next one would be limit x approaches 3 from right of fx. So you have to use this one. This one plus, this one no plus. Now you use 4x plus 1. And substitute 3 to here, you get 13. So the limit is equal to 13. So C, F3, This one was 13, so the limit x approaches 3 of fx is equal to 13. It's from the definition. If you have 13, this one 12. So this one does not exist. It should be equal. This one both equal. So limit 3. No plus or minus sign here. It's 13. If this one 13, this one 10, this one does not exist. Okay, so since this one is 13, this one is 13, this one is equal. Equal to 13. Therefore, continuous at x equal to 3. Okay, next question would be something like this. Find the value or values of k if fx equal to x square minus 2, k x minus 4, this one x less than 1, this one x greater than equal to 1, is continuous at x equal to 1. It is continuous, so find the value of k. So what you need to do, use the same 3 step. So first, f1. Why 1? Because continuous at x equal to 1. f1. f1 is this one. So it's k times 1 minus 4. You need to find this k. Okay, step 2. You find the limit. You already used this one, greater than 1. So use limit from left. So limit x approaches 1 from left. This one from right, this one from left. You already used this, use the other one. So this one, fx is equal to limit x approaches 1, x square minus 2. So this one is 1 minus 2 is minus 1. It is continuous, right? So from C, k minus 4 must be equal to minus 1 because continuous. If continuous, this one must equal to this one, right? So k is equal to minus 1 plus 4 equal to 3. So you only have one value of k. We have finished chapter 1. Now we go to the chapter number 2. Chapter number 2 is differentiation. First, we look at the definition of derivative. So f prime x is equal to the limit of fx plus h minus fx over h. That's the formula. Okay, so this is the formula. Let's look at an example. Okay, example number 1. Fx is equal to x plus 4. So we need to find f prime x using the definition of derivative. So what you need to do, if you look at the formula, you have one fx plus h, the second one is fx. So first find f, we already have fx, so fx plus h is equal to, we substitute everything here into x. So you have x plus h plus 4. Okay? According to the formula, next is you minus and then you divide by h. So this one is fx plus h minus fx. You get this one, x plus h, x minus x, 0, h, 4 minus 4, 0, you get h, divide by h, so divide by h, this one you get equal to 1. X minus x, 0, h minus 4 is, h plus 4 minus 4 is h. That's why I get this. So the limit of h approaches 0, 1. This one 1, so the answer is 1. So f prime x is equal to 1. Okay, another example. Fx is equal to x square plus 4. So fx plus h is equal to x plus h square plus 4. So this one is equal to x square plus 2xh plus h square plus 4. So if you minus this, fx plus h minus fx, you will get x square minus x square, this one 2xh plus h square, 4 minus 4, 0. Okay, so this one you can factor out h, so you get h 2x plus h square, because your objective is to get rid of h from the denominator. So divide by h, this one divide by h. According to the formula, this is the formula, divide by h. Okay. So this one is equal to 2x plus h square. So now f prime x is equal to limit h approaches 0 of this one, 2x plus h square. So the answer is 2x. Differentiate this, 2 go to the front, 2 minus 1, you get 2x. Another example, fx equal to square root x plus 4. So fx plus h equal to square root x plus h plus 4. Like this. So you minus this, fx plus h minus fx, you get equal to square root x plus h plus 4 minus square root x plus 4. If you have like this, what you need to do, as usual, involve radical, multiply with the conjugate. So this one is equal to square root x plus h plus 4 minus square root x plus 4 times square root x plus h plus 4 plus conjugate is minus and plus x plus 4 over square root x plus h plus 4 plus square root x plus 4. As usual, this one just copy. So x plus h plus 4, and this one also you just copy x plus 4. Finish for the numerator. Don't waste your time multiply one by one. So the denominator x plus h plus 4 plus square root x plus 4. Okay, so you will get 1 over square root x plus h plus 4 plus square root x plus 4. From here, x minus x 0, 4 minus 4 0, and then you left with h. This one h and h, 4 and 4, so you have h over this one. So f prime x is equal to limit of this one. Limit h approaches 0, 1 over third x plus h plus 4 plus square root x plus 4. So this one 0. So you have limit, no more limit, 1 over square root x plus 4 plus x plus 4. It's like 3 plus 3, you get? X plus x, you have 2x. So this one, 1 over 2 square root x plus 4. You just imagine this like star plus star. So you have 2 star. Another example, fx equal to 1 over x plus 4. So fx plus h is equal to 1 over x plus h plus 4. So if you minus this, fx plus h minus fx, this one you get equal to 1 over x plus h plus 4 minus 1 over x plus 4. So what you need to do is to simplify the expression. So you have x plus 4 minus this one, x plus h plus 4 over, you have this, x plus 4, x plus h plus 4. And this one is equal to minus h, x minus x, 4 minus 4 is minus. You must be able to cancel as usual. If you cannot cancel, it means that you made the mistake. This, like this. This one you copy. X plus h plus 4, x plus 4. So from here, I continue here. So f prime x is equal to limit h approaches 0 of everything here minus h over x plus h plus 4 times x plus 4. Divide by h. So you have another h. So you must be able to cancel. So if you cancel, and then you substitute 0 here, you have 1 over x plus 4 times x plus 4, which is equal to x plus 4 square. And with minus sign, this minus sign. So finish. Find the derivative using the definition. Okay, the next thing is the differentiation. Very quick one. I hope we can finish by another 1 hour until integration, inshallah. Okay. Find the derivative. So fx is equal to 3x power 8 minus 2x power 5 plus 6x plus 1. This one very easy. 8 times 3, 24 minus 1. So you get x power 7 minus 5 times 2, 10. X, 5 minus 1, 4. Plus, if you have power 1, just put 6. Number, 0. Very easy. If you have fx is equal to 4x squared minus 1 times 7x power 3 plus x. If you have two terms like this, you need to use product rule. The formula is simple, vu prime plus u v prime. So one is u, one is v. So this one is equal to f prime x is equal to, first v, you copy this one, 7x cubed plus x. This one v, u prime. So 4x squared minus 1 prime plus u, you copy this one, 4x squared minus 1, and then this one, differentiate. Find the derivative, so prime. So if you solve this, you will get this one, copy. The derivative of 4x squared minus 1 is 8x. So this one, copy. The derivative of this one is 21 x squared plus 1. This is product rule. You also have quotient rule. Let's say you have fx equal to x squared minus 1 over x power 4 plus 1. Quotient rule. So the formula is v u prime minus u v prime. I like this one because v u prime plus u v prime for product rule. Quotient rule v u prime also, but this time minus. Divide minus, multiply plus over v square. One is u, one is v. So f prime x is equal to v, this one v, x power 4 plus 1, u prime, you get 2x minus u v prime 4x divide by x power 4 plus 1 square. And then you can simplify this if you want to. This is quotient rule. We also have to find the derivative for trigonometric function. So let's say you have fx equal to x square tangent x. So 1u, 1v. So f prime x formula vu prime plus uv prime. So v is tangent x first. Differentiate this, the derivative is 2x plus copy x square u. The derivative of tangent x is secant square x. Finish. Very easy. Next is log. So let's say you have fx is equal to log 2. You need to memorize the formula. For log is, the derivative is equal to, first you copy, and then you differentiate, find the derivative of the inner function and put here. So this one is 2x. And then for log, don't forget ln of 2. 2 comes from here. This one. Next one is log base e. Ln is log base e. This one is the same thing. So fx is equal to log x square plus 1. The difference is only ln 2. Derivative over copy. So the derivative is 2x from here over copy. You copy x square plus 1. No need to put ln because log e is 1. So you don't need to put it there. Next one is exponent function. Fx equal to exponent, number here, the power have x. If you have x power some number, that is not exponential. Exponential function is x is at the power part. This one very easy. So f prime x is, first you copy, and then you find the derivative of this. Derivative of this, you get cos x. And then because this one is 2, so you need to add log 2. Okay. If you have fx is equal to e power sin x, maybe we use cos x this time. So f prime x, you see the difference. Copy, find the derivative, negative sin x, and then don't put log because this one is e. Log e is 1. Very easy, right? Next one is chain rule. You have fx equal to x cubed power 2x minus 4 power very large, for example 4. Power 2 is okay, very easy for you to do. But now let's say you have power 4 or power 100, it's not easy. But using chain rule, your life becomes simpler. Don't worry. So fx is equal to, so chain rule is very easy. First, you differentiate the bracket. Like this. So, for example, you have x power 4, the answer is 4x power 3, right? So you copy everything here, copy everything, Ctrl C, Ctrl V. So you get this. The next part here is to find the derivative. So x cubed plus 2x minus 4. So the answer is 4x cubed plus 2x minus 4 power 3. So the derivative of this is 3x squared plus 2. Finish. Remember, first find the derivative of the large one, the outer function, and then the inner function. If you have another inner function, find the derivative of the another inner function. It's very easy. Let's look at another example, involve the trigonometric function. Let's say you have fx equal to 4 sine x cubed. So this is the outer function, this is number 2, this is number 1. Okay, so f prime x is equal to 4, differentiate this, you get cos x cubed. This one, number 1. So number 2, you have to find the derivative of the inner function. So the answer is 3x squared. Another example, fx equal to x cubed plus 2x minus 3 power minus 1. Usually you have 1 over. So I simplify this so that you get minus 1. So this one, f prime x, the derivative is outer function. So you have negative power negative 2. So x cubed plus 2x minus 3 times 3x squared plus 2. Very easy. That is chain rule. Implicit differentiation. Let's say you have y cubed equal to, let's say you have y equal to fx. So if you find the derivative of y, you need to find the derivative of f. So d dx y is equal to d dx fx. Or you can just write dy dx equal to df dx. Very easy, right? Let's say now you have y cubed equal to fx power 5. So you d dx here. So you have to d dx here. Okay. So this one, if you find the derivative, you have 3y squared. Since y is a function of x, y a function of x, so you have dy dx. This one, chain rule. So 5 fx power 4 times df dx. Okay? So dy dx is not finished yet, is equal to 5 fx power 4 over this one, 3y square times df dx. Okay, let's look at the real example. Y power 3 is equal to x square plus 3x plus 4 power 5. So, we want to find the dy dx of this one. So, you have d dx x square plus 3x plus 4 power 5. Okay, so this one, 3y square at dy dx equal to, chain rule, 5x square plus 3x plus 4 power 4. Derivative of this, 2x plus 3. Don't forget the bracket. So, dy dx is equal to 5x square plus 3x plus 4 power 4 over 2x plus 3 divided by 3y square. Very easy, right? Okay, another question. 5y square plus sin y equal to x square plus 3x plus 4 power 5. So, if we ddx everything, so you ddx this one also. So, you get 10y. Because y, you add dy dx. This one, cos y. Because y, you add dy dx. This one is 5x square plus 3x plus 4 power 4. Derivative of this, 2x plus 3. You need dy dx. So, factor out dy dx. We use green color now. Dy dx 10y plus cos y equal to everything here. 5x square plus 3x plus 4 power 4 2x plus 3. So, finally, dy dx is equal to 5x square plus 3x plus 4 power 4 times 2x plus 3 over 10y plus cos y. Equation of tangent line. So, you only have one formula. Y minus y1 equal to dy dx. X minus x1. One formula. Just remember this one formula. So, find the equation of tangent line of fx equal to x square plus 1 at x equal to 2. So, first find f prime. So, f prime x equal to 2x. Substitute 2. So, f prime 2 is equal to 2 times 2, 4. Okay, so you have this. You already have this one. So you need to find this one. F2. F2 is equal to, substitute into here, 2 square plus 1 is equal to 5. So the formula is, the equation is y minus 5. This one is y equal to 4 x minus, x minus 2. This 2. So you can rewrite this. You get y equal to 4x minus 3. Let's look at another example. Fx is equal to 2x squared at 318. Now you are given y. So your life is simpler. 4x. So f prime 3 is 4 times 3, 12. So y minus 18 is equal to 12 x minus 2. X minus 3. So y equal to 12x minus 18. Local linear approximation. How you want to do approximation? So find the local linear approximation of fx equal to set x. For example, you want to find fx equal to set x. So find the local linear approximation at x equal to 4. So what you need to do is at x not equal to 4. Okay, what you need to do is you have one formula. It's like y minus y1 equal to x minus x1 actually. F x equal to f x not. This one is not equal to. Approximately equal to. Okay. Plus f prime s naught. See everything s naught. Okay. Times x minus s naught. S naught, s naught, s naught. This one is called the dx, the differential of x. This one is dy, the differential of y. Sorry, everything is differential of y. This part is differential of x. Everything here is differential of y. Because y minus y1. Y minus y0 is everything. Dy. So, first find the f prime. So, you get 1 over 2 set x. Substitute s0, which is 4. 1 over 4. And then find f4. F4 from here, you get 2 from this one. Okay. So now, what you need to do is apply the formula. So, set x is approximately equal to, you have f4, which is 2. This one. First one. Plus, this one is f prime x naught. So, 1 over 4. And the differential of x is x minus 4. Now you can simplify this and you will get x plus 4 over 4. So you can find, for example, square root of 4.3. You just substitute 4.3 here and you get the approximate value of 4.3 square root. That is the usage. Okay, use differentials to estimate 3.98. Square root of 3.98. This time, you are not given a function. So, you need to find the function. This is the question. So, you need to define the function. It's very easy. You use fx equal, first you copy. Copy everything. So, you copy the radical symbol, square root. And then, instead of the number inside here, the radical, you change to x. That's it. So, and then, you need to have your s naught. S naught should be near to this one. And if you take the square root, you should get whole number. So, the nearest one is 4. You don't use 16, because 16 you will get 4. This one is 3.98 near to 4. Square root of 4 is 2. So, the answer should be 2 point something or 1 point something. Okay, and then you find the derivative. 1 over 2 third x. F prime 4. This one you get 1 over 4. Next is F4 is 2. Your dx is 3.98. This one, the value 3.98 minus the 4 minus 4 s naught. So you get what? Minus 0.02. Okay. So next is (3.98) approximately equal to this one 2 plus this one 1 over 4 times minus 0.02. So you should get the answer is 1 point something. 1.995. This one is approximation. Okay. Let's look at another example. Square root 4.02 minus 1 over square root 4.02. This time you have 2 like this. Don't worry. It's just a simple one. First, your fx equal to, so you copy the radical minus 1 over, copy the radical, change the radical into x. Okay, so your s naught, obviously the s naught is 4. So s naught is equal to 4. So f prime x equal to 1 over 2 third x plus 1 over 2 third x cube. So you find the f prime 4. So you should get 5 over 16. Just substitute 4 into here. I don't want to show the answer. And then this one dy is equal to 5 over 16. The differential of y, this one, times x minus x naught is 4. 4. So 4.02 minus 4. So you should get 1 over 160. So everything here, square root 4.02 minus 1 over square root 4.02 is approximately equal to F4. I forgot to find F4. F4 is 3 over 2 So 3 over 2 plus dy. 1 over 160. So you should get 181 over 160. 181 over 160. Okay, finish. The next one is application of differentiation. First, we go through how to sketch the graph, and then we will look into the integration and some application. Alright? Okay, so sketch the graph of fx equal to x square minus 4x plus 3. So you have even function. You want to sketch the graph. Very easy. First, you find y-intercept. And then x-intercept. So y-intercept is x equal to 0. So when x equal to 0, you substitute 0 into here, y equal to 3. 1 is 0, 3. So if you plot the graph, this is the y-axis, this is your x-axis. So maybe 1, 2, 3. 1, 2, 3. So the first one is 0, 3. So this one. 1 point. And then x-intercept. X-intercept. This one equal to 0. So x square minus 4x plus 3 equal to 0. So you factor out this. Equal to 0. X 1 times 3 is 3 minus minus. So x equal to 1 or x equal to 3. So 1 0 and 3 0. So now you already have 3 points on the graph. The next is critical point. You need to find the critical points, or 1 point maybe, we don't know. So f prime x is equal to, you differentiate, you get 2x minus 4, and this one is equal to 0, so x equal to 4 over 2 equal to 2. So when 2, you have something. So if you substitute 2 here, you will get minus 1. So on the graph, you declare this point. This one, 2 minus 1. This one. What point? We don't know yet. But this is a critical point. This is a critical point. From here. Okay. So, increase or decrease? X, you have 2. So you have f prime and then f. Okay, 1 is less than 2, 1 is greater than 2. Less than 2, for example, 0. Substitute into here, you have negative. So f decreasing. Greater than 2, for example, 10. Substitute into here. 2 times 10, 20. 20 minus 4, positive. You only care about the sign. So this one is increasing. If you look back at the graph, okay, at this point, this one is 2, so here it is increasing, sorry, decreasing, and after 2, the graph is increasing. So you are interested in to know whether concave up or down, because if increasing, you can increase like this, and you can also increase like this. You don't know which one. The same goes for go down. So now the next one, after you find the increase and decrease, what you need to do is check for concavity. Concavity. So you need to find the second derivative of x. So the second derivative of x is equal to 2x minus 4. You find the second derivative is equal to 2. The critical point is 2 just now. So this one is f prime, and this one f. So you try 0 less than 2, positive, so concave up. Greater than 2, for example 10, also positive, because there's no x, always positive lah. So this one also concave up. So in the graph here, it should be concave up, this one, and go down, concave up like this. So the answer is like this, concave down. Here, go up again. Actually, you can see that the graph is like this. Since no change in concavity, no inflection point. If you have down up or up down, then you will get the inflection point. Next, let's have a look at odd polynomial function. Okay, let's say your function is fx is equal to x cubed minus 3x plus 2. So f prime is equal to 3x squared minus 3. And this one for the critical point. Okay. So this one equal to 0, so we have x equal to 3x squared equal to 3, x equal to plus minus 1. So your graph would be something like this, y, and then you have x, and then you have 1, minus 1. So this 2 point is the critical point. This one critical point. Substitute 1 into here, into f, you should get 0. Maybe you have another one too. Substitute minus 1, you should get 4. So you have 2 points here. Now you want to know increase or decrease. Okay, let's say if you have 0, y intercept 0, so 0, 0, you have 2. 1 point here. Okay. Now increase or decrease. So your table, x, you have 2 points, minus 1, and you have 1. So the f prime and f. Less than minus 1, for example, minus 5. This one between minus 1 and 1, for example, 0. And here, for example, 5. So f prime is positive, negative, positive. So this one go up, down, and this one is increase. Up, down. So this one is maximum point. Down and up. This one is usually minimum point, maybe. Okay, so you go up until minus 1, and then you go down. You go down, and then you go up. Okay, now for the concavity. So f double prime x is equal to 6x. So if this one equal to 0, you have x equal to 0. So if you do the table, x, you have minus 1, you have 0, and you also have 1. F double prime, and then f, this one you have minus, minus, plus, plus. Both you have down, down, up, up. So changing. So here is inflection point. Changing up and down. So if you look at the graph, this one should be, if you go down here, and then this one up. Inflection point. Down and then up. So this one inflection. Like this. So that's it. Your graph is finished. Increasing, decreasing, and concavity. Okay. The third type of graph that you need to know is rational function. So fx is equal to x minus 1 over x plus 2. This one usually you have asymptote. Okay. Vertical asymptote. Happen when the denominator is become 0. So x plus 2 equal to 0, x equal to minus 2. So if you sketch the graph now, you have this is your y-axis, this is your x-axis. Sorry, better line, y-axis. So you have minus 2, minus 1, minus 2. This is your vertical asymptote. Don't cross this line. Your horizontal asymptote, find the limit. So the limit of x approaches positive infinity of x minus 1 over x minus 2. So this one divided by x. This one also divided by x, so you get this one equal to one. Actually, if you find the negative infinity also, you get 1. So y equal to 1 is the horizontal asymptote. So your graph is either like here and here, or the bottom one. Let's have a look at when x is equal to 0. X equal to 0, y is equal to minus 1 over 2. 0 minus 1 over 2. So this one 1. So about here. So 1 point is here. So of course, your answer should be like this and like this. You finish. But of course, for the sake of the exam, you also need to find the increase or decrease. So f prime x is equal to 3 over x plus 2 square. So this one, the critical point is happen when the denominator equal to 0. So x equal to minus 2. So, okay, sorry. And it happened to be the vertical asymptote. So what you need to do is increase or decrease minus 2. Let's say this one f prime, this one f, this one minus 4 and 0, this one plus plus. So up and up. Like this. Both going up. Up. This one also go up. No problem. And the concavity, f double prime, second derivative is equal to minus 6 over x plus 2 cube. So equal to 0, so also this one the same. So you have minus 2 here. Second derivative f, let's say you choose minus 4, 0. So 1 is plus, 1 is minus. You substitute here into this one. Okay? So this one concave up, concave down. If you look at your graph, one concave up, one concave down after minus 2. So you are good to go. Finish graph sketching. Let's look into integral. We need to find the integral using substitution method. Substitution method. First, to find integral, x dx is equal to x power 1, so 1 plus 1 over 1 plus 1 plus c. So this one is x square over 2 plus c. This one is very easy. So the one that I will show you is the substitution method. So x square plus 1 power 50 dx. Power 50 is not easy. You can expand, maybe using the binomial expansion, but it's not easy to solve this. However, we have the power of u substitution. Okay, let's make this even better. We add 2x dx here. How to solve this? Okay, first we need to find u. U is the one that has the highest power. So this one power 1, this one power 50. So this one is our u. Okay, so let's take u equal to x square plus 1. Find the derivative. Du equal to 2x. And don't forget Mr. dx. This one becomes 0. So if you look carefully here, 2x dx is the same as this one. So what we need to do is just change this. Everything is u power 50. This one is du. Now it's very easy. 51 over 51 plus c. Then u is x square plus 1. So x square plus 1 power 51. Over 51 plus c. U substitution. Another example. Let's say we have integration of 1 over x over 3 minus 8 power 5. dx. So your u is inside this one. U is equal to x over 3 minus 8. So du is 1 over 3 dx. Our problem here no 1 over 3. So what we need to do is we add. So this one should be dx over 3. So we add over 3. If we add 3 here, we multiply 3 to cancel out again. So now this one can become 3 1 over u power 5 dx over 3 is dx over 3. So it's du. So this one is equal to 3u minus 5 du, and it is equal to 3u minus 4 over minus 4 equal to minus 3 over 4, and u is x over 3 minus 8 minus 4 plus c. Another example on trigo function. Sin x plus 9 dx. 9 dx. So u is x plus 9 du dx. So this one is equal to sin u. Du is dx, like this. So you get sin minus cos u plus c. This one is minus cos u is x plus 9 plus c. Definite integral 1, 2. Now you have limit x dx equal to x squared over 2. So 1, 2, and then you substitute 1 by 1. 2 square over 2 minus 1 square over 2. If you solve this, you get 3 over 2. No problem. If you have something like 40x, it should be the smaller one and then the higher value. So what you need to do is to reverse this one. If you reverse, you put minus sign. No problem. This one, now you can easily integrate and you get the answer is minus 8. Use substitution for definite integral. 0 to x times x squared plus 1 power 3 dx. So u is equal to remember the highest power. So x squared plus 1. So du equal to 2x dx. No 2 here. So add 2, divide by 2. Very easy. So, sorry, you already have x. X dx. So you have x dx, but no 2. You add 2. So 2x dx divide by 2. Okay. So now 1 over 2. 2x dx is du, and this one is u. U power 3, 2x dx is du. But now, this one is x. Now it become u. So you have to change. When x is 0, u become 0 plus 1 is 1. When x is 1, u become 1 plus 1 is 2. Oh, sorry. U is 2. X is 2. 2 square plus 1 is 5. So this one is 5. So if you solve this, you have u power 4 over 4, 1 over 2. From 1 to 5, you just substitute into u. You don't have to bother about y. So you should get 78. Okay, so application of integration. Let's say you have this graph y, and then this one x, one here, and then the one here. You have y equal to x square, and then you have another graph x equal to y square. Find the area of this region, of the shaded region. How to do this one? It's very easy. The area is, you have two ways to solve this. One is top minus bottom, the other one is right minus left. Top minus bottom, you integrate against x. Right minus left integrates against y. So the area is equal to, let's say top minus bottom. So the top function is, okay, we look at the bottom function. For top function is x square, the top one is y equal to set x. So this one is integration of 0, 1. So set x minus x square dx. Top minus bottom. So you will get 1 over 3. You can also solve the same problem using y. Let's draw again. You have y, you have x, y equal to x square. This one, okay, the right function minus left function. So right function now become set y. The left function, because this one is y equal to x square. This one x equal to y square. This one you don't have to do anything. So this one is y square. You need to find the region, but now you want to integrate y. You should get the same answer, but different technique. From 0 to 1. Why 0 to 1? Because this one is 1. 0 to 1. 0 to 1. So set y. It happened to be like the same thing, but this one by luck. Alright? Y square dy. So this one is equal. If you solve this, you should get 1 over 3. This one right minus left. Okay, that is for area. Now we want to find the volume. Last one. The same graph. We have, for volume, we have washer. I will divide this into 4. And then you have share. This is the last part. Thanks for continue watching. So you have this, the same graph, y, this one, and this one. Okay, washer is when you rotate, you have this region, you rotate x-axis, you rotate like this. This region rotate. So what you need to do is, the center is here. So this is your circle, and then you have another big circle. So the washer method is you move many circles from here, small, become bigger circle. So you have many circles. You add everything. To add, you do integration. So a circle, the area is pi r square. So V is equal to pi times big circle. Big circle is this one. So this is y set x. Y equal to set x. So set x pi r square, right? Pi r square. So don't forget the square. And the integration from 0 to 1 minus small circle. This one is x square. So x square square, and then dx. The same problem you can solve using shell. I draw the graph again. This x. One is set x, y x square. Okay, shell is like this. This one also rotate about the y-axis. Sorry, the x-axis also. Okay, first this is the center. You rotate, you have circle. But instead of you have a circle, many circle, you go from left to right. Now you have cylinder from the center to the top. So you have cylinder like this. So this one, this is your height. This is your radius y, and your height is right minus left. So this one is set x, and this one is sorry, not set x. This one is set y, and this one is y square. So V is equal to, for cylinder is 2 pi. 2 pi from 0 to 1. And then you have R. R is y. This one. Times the height. Height is set y minus y square. And dy. Okay. If you rotate against the y-axis, like this, same graph. Yeah, like this, and like this. So, rotate now about the y-axis. So, the circle, now, for washer, this one washer, is this one. And this one. Okay. So, you move circle from down to top. Okay, so V now pi dx become dy because you move down to top. So 0 to 1 also big one minus small one. So dy. So this one also must be dy. Y square. This one is the big one, and the small one is set y. So, set y minus y square. Okay. And finally, the last one for today. Y. One. Like this. You have circle. This one go down because cylinder. So now you move left to right, from the center to right. So it should be dx about the x-axis. So V is equal to, sorry, I forgot 2 pi. So this one is x. So x from 0 to 1, and this one is set x. This one is x square. So set x minus x square. Okay. What if I move the I move this one. This one x. I rotate about the y-axis. This one shell. I have this. I have this. But now the rotation is about y equal to minus 1. What to do? Okay. So you have the circle. Circle now. This is the center. Circle. This is the height. So, this one is 1. Oh, sorry. Rotate about the x-axis. This one is 1 and this one is y. So v equal to 2 pi. Now it become y plus 1 and the height h lah, dy. This one is right minus left. Washer is the same thing. I draw the same graph. This one washer. 1 x, rotate here, 1 here, 1 here, say this one. Oh, 1, and then rotate here. Y equal to minus 1. So your circle is, you have two circle. Oh, sorry, the center is here. So like this, and the big one is this one. So you have to add 1. You don't care about the minus sign. Length is always positive, right? So this one is x. This one is x square. So this length, it should be v equal to pi. The big one is x square plus 1 square minus sorry. The big one is x plus 1 square minus small one, x square plus 1 square dx. With that, I think that's all. So I want to say thank you for watching, and I hope that everybody will pass the exam. See you again next time.